Oh, yeah.
presentation.
Look at that. There we
Today
go.
will be given by Carlos from Amazon about AI native testing. We're excited to have you, Carlos. Thank you.
Oh, no, that's the family feather. Okay, darn. That was a Zoom.
Yeah, okay.
Yeah, we're good.
Awesome.
We're
thank
good.
you.
You look great.
Hi, my name's Carlos. I want to talk today about, I should use the microphone.
Yeah, maybe grab that one. That's more reliable. So try it.
Testing.
Okay.
Testing.
Yes.
It works. Awesome. All right. Hi, my name is Carlos. I'm a senior principal at Amazon, and I'm here to talk about AI native development and testing, and particularly testing. A little bit about me. I've been at Amazon since 2009. I did take 4 years to work at Google, and I came back to Amazon about 2.5 ago. So I am a Zoogler, and I know a lot about what you guys talk about today as well. And we have this problem where we're able to generate code 10x faster than we could 2 years ago, and that's pretty awesome. You just give a prompt, and you can get 10,000 lines of code very easily. And everybody's like hyper focused on how fast can we generate code. But the real problem, the real bottleneck that I'm concerned about is that we don't really have the ability to test that code at the same rate at which we are generating. Our test infrastructure is not really set up to run at 10x. And most importantly, when that happens, there's going to be two things in tension: product quality and speed of delivery. And guess what? Speed of delivery is always going to win. It's just what happens. And so I think we have sort of this perfect storm where everybody's focused on the development side of things, and we're not focused enough on the testing side of things. And we're possibly creating this really big problem. And so that's what has been kind of consuming my life for the last few years. And the way that I started doing this is I would go to one team and I would say, hey, like, think about this. And it kind of felt like going and like realigning their compass to point a certain direction. And eventually, after doing this many, many times, it kind of felt like herding cats, because I got really tired of doing that for every single team. And so I thought, rather than realigning like every single team's like compass, like, can we create some sort of North Star so that you can just point at the North Star and say, this is a direction that we should be, heading in this general direction. And the way that we set out to do this with a bunch of other principals at Amazon was we were going to paint this destination of where we want to take the company. And generally, a destination is like some beautiful thing. Here you've got Gemini, of course. I use Gemini for this. You've got this beautiful scenery, and your destination is this curvy line. And eventually, you get to this beautiful village in the valley, and that's inspiring and makes people happy. I'll come back to this image. And you don't really have to read what's in the slide. Don't worry, it's very small, fine print here. But the way that we kind of envision like how AI native testing fits in here is kind of this workflow of a bunch of different agents. And I'll just highlight the parts that are really important here, which is the first one is we have the ability to generate specs from code. And we do that pretty aggressively. We have 25 years of legacy code at Amazon. Nobody really understands what some of that code does, but now with LLMs, you can generate much better specs. So we have specs of the present and the current systems. We have specs in terms of what engineers are telling the LLMs they want to build. And so, we start with specs. And from the specs of what the system does today and the specs of what somebody wants the system to do tomorrow, we can generate some sort of a plan. And so this is an agent consuming all this data and generating a plan. And then another agent maybe critiquing the plan and saying, I don't think your design is right. Think about this or that. And so there's sort of a loop there. And once you have an execution plan, then there's some sort of agent here that will be a supervisor for the execution of this. So there may be an agent writing code, there may be an agent critiquing the code, and they work out with each other what they think the right code is, and there's an agent writing tests, and there's potentially other agent like reviewing the tests and so forth. This may not necessarily look exactly like this, but the high level bit here is that there's agents interacting with each other, and there's executing on a plan. And then there's a bunch of things that eventually get pushed abroad, and there's a couple of escape hatches for real humans to interact. But for the most part, the beautiful thing here is that this is an autonomous system, minus escape hatches. Now, if you truly want this to be autonomous, then testing is paramount here. You have to have proper validation for this entire thing to be autonomous. Otherwise, we're going to be in this bad situation where we're just creating slop. And the high level order of it here is that testing is always little green circles. And it's basically all the different places where you can be testing, injecting tests. So we can generate testing in the spec, we can be generating testing as we're reviewing the code. We can test the tests, we can test production metrics, several places where there's feedback and data that we can get. And so this is like the destination that we want to get to, this autonomous development site. Remember I told you I was going to come back to that. So this is what it looks like in real life. There's a bunch of potholes, there's a bunch of broken down cars. I don't know about you guys, but this is what my life looks like. And that is pretty much every company that I've ever seen. This is what it looks like in reality once you start kind of diving deeper. And so getting to that high, beautiful valley is going to be a little bit difficult here. And, just to set the same vocabulary here. So there's unit tests, integration tests, and end-to-end tests, and they cover different things. And one of the things that are kind of problematic for us is that traditionally at Amazon, we run unit tests in the inner loop, and then we run integration and end-to-end tests in the outer loop, which is quite different from the way Google does it. You guys did a much better job shifting testing left. We didn't have a mono repo, so we didn't have to shift left. We have tens of thousands of micro repos, so we can get a little bit lazier about that. But as a consequence of that, we have the system where most of our integration end-to-end tests are running in the outer loop. And my assertion here is that if you're going to have an AI native systems where LLMs are writing code autonomously, like getting feedback here is just too late. So my hot take here is that the outer loop is dead. That's a hot take. You don't have to agree with it, but that's what it'd be, somewhat stir the pot here. But the point is we have to figure out how to shift all these signals earlier in the cycle. We have to figure out how to give the LLMs the signals on where the code that they generated is actually working. So I wanted to put a framework in place to align a bunch of people in the company to move in this direction. And we came up with 5 different pillars so that, as we're thinking about what investments we'll make in the company, as we're thinking about how we evolve our toolings, the question that I want to be asking is how aligned are we with these pillars? So I wanted this to be sort of a thought framework for our evolution here. The first one is test coverage. And what I mean here is we have to improve our test coverage. This is beautiful AI slop. This doesn't actually look like code, but I asked Gemini, to generate some code. This code will never compile, but it kind of looks like code, so I left it in there. The point is that most of our services have insufficient test coverage, and we know this. And so we can't get to an AI native system unless we improve both the line coverage, the branch coverage, just test coverage in general. So that's one of the directions in which we need to be moving as a company. And this is a place where LLMs actually provide a great opportunity because we have specs. If we don't have specs, we have the ability to generate specs. And we can feed these specs to auto generation LLMs, auto test generation LLMs, and we can significantly increase test coverage for everything that we have. So this is a great opportunity. I'm like super excited about this because I know some of the coverage that we have, test coverage that we have in some of our systems, and it's pretty scary, but we can be fixing this. So that's one of the pillars that I think we need to evolve to get to this AI native system. An example of something that we're doing and something I've been working on is UI testing has been pretty difficult for us. There's a lot of frameworks. UI testing is notoriously flaky, just in general. About 2 years ago, we started investing in an LLM-based system where you just give an LLM instructions in English. Hey, I want you to go to the Amazon store, search for Harry Potter, make sure Harry Potter and the Sorcerer's Stone is in the search results, add it to the cart, make sure it's in the cart. I'm just giving you a test in plain English. No Cypress, no Selenium, no Appium, just plain English. And what we found is that we're able to run much more interesting tests, and they're much less flaky. We've reduced our flakiness significantly by having LLM-based execution of these UI tests. And everything that goes through the Amazon store starts in the UI, so UI testing is a big deal. That's an example of a place where we're using LLMs to increase coverage. The next pillar is stability, and we've talked about stability a lot today. So kind of preaching to the choir here, but I had to explain to a lot of these executives why testability was a problem, because I needed them to align a bunch of funding and a bunch of investments towards this. And so we talked about this today as well. Testability is the bane of my existence and the bane of all of your existences, I'm sure. And there's sort of three parts to this, because the test code is unstable. And I think there's it's pretty low hanging fruit to fix unstable tests. I think we're all getting there. And product bugs definitely need to be fixing those. But the thing that goes through most of my time is this big one here, which is the test environment instability. And the reason this is difficult, this is what Amazon.com looked like the day I was hired in 2009. Every one of these little dots is a microservice calling other microservices. So creating a test environment for something like this is very difficult. And this was 16 years ago. It looks like much more terrible than this today. And so we've tried to create test environments in the two things that we always run into. Number one is availability, because we never really maintain or test stacks at the same level of operational rigor as our production stacks. And the second one is test fidelity, because they just simply are not ever going to be an exact copy of prod. At the end of the day, it's a copy. And so this concept of creating test environments and hoping that they will be just like prod is something that we've been trying for 20 years, and I don't think it's going to ever work. So what we're moving towards is actually testing in prod. And I don't mean that in like, a YOLO kind of way, but like, how can we do this safely? And this is my idea. There's great white papers from Uber that started doing this a number of years ago that got me really excited about this. But the idea is production is high fidelity, high availability environment. If we can test safely in production, that's great for these very complicated large ecosystems, right? And so we hit production, we mark the transaction as being a test transaction. And then here we have routers that proxy test traffic to the test environment, the SUT, the service under test. But other than that, everything else is product. It's just rerouting a specific part of the graph to test. The other part of this is something at the Amazon store. You always have unintended consequences when you're doing something. Maybe I don't want to charge a customer credit card if I'm replaying some traffic. So we have to avoid all these like unintended consequences to downstream services. And so that's the other part of this is we have to have ways of modifying certain behaviors like charging credit cards, shipping items, and things like that. And the last but not least is you have to think about how you're writing data, because now you have test transactions going through production services. Are they going to be written to production databases? How do you keep those things safe? Non-trivial, lots of work, but this is the direction that we're moving, and I'm very excited about this and how to make it safe. Pillar number 3 is I call it adequacy. And what I mean by this is, and we talked about this today a lot as well, which is the traditional way of running things that we've been doing forever is we have a full regression test suite, and we run those same tests for every single change, regardless of whether the change is high risk or low risk. And so we need to be a little bit smarter about test case selection. Google and Meta, you guys have been doing this for a while. I think we're catching up with a lot of this, but selecting the right, analyzing the risk of a particular change and tailoring the test that you run for that specific change. That's one place where we can be running more adequate tests for that particular change. The other one is, I'm actually very excited about this. There's an extension to mutation testing. So mutation testing, great technique for unit tests. You just change production code and you rerun your test. You introduce synthetic bugs in production. You rerun your test. If your tests don't catch this bug that you just introduced, then your tests are bad. They're garbage. And so we're taking this to the next degree, which is we're changing production code, not production code, we're changing code and we're introducing all kinds of synthetic bugs. And then we're seeing how many of those bugs are actually caught by any of our validation. And this gets into the business of testing the tests, which is something that I've been increasingly worried about as we have LLMs generating tests. We have to test those tests. And ideally, we have some sort of metric for every one of the validation pipelines that says, hey, your current test strategy is letting 28% of these synthetic bugs that we're trying to introduce go right through. Gemini, I love that it named this the Bug Injector 3000. That's pretty cool. I think I'm going to name that, like when we put this in production, that's going to be the name. The next pillar is efficiency. And what I mean by this is there's a lot of our test infrastructure that isn't necessarily set up to be running at 10x. I'll give you a concrete example of something we're working on, which is mobile testing is a big deal to the Amazon store. I'm a dinosaur. I buy on Amazon on the web. I think I'm the only person left in the world that uses a website to buy from Amazon. Most of our customers are buying from our mobile app. Yet, 2.5 years ago when I came back to Amazon, most of our testing was on web. So I thought, this is a disaster waiting to happen. We're not really testing the way that our customers are using us. So you have to really double down on properly testing on mobile devices. And we had these labs of 30,000 mobile devices, a bunch of lab engineers trying to maintain these devices, and they were like absolutely painful to do. And I thought, this is going to scale. As we depend more on LLMs and increase the rate at which we're generating code and validating code, like this isn't going to cut it. And it's not my expertise to manage the lab. So phase 2 about 2 years ago was AWS does a really good job here. And I'm lazy. If they do a better job, that's great. So there's this part of AWS called AWS Device Farm, and they give you physical devices, but they manage all that infrastructure. So that's great. That got us out of the business of having physical labs that we had to take care of. But still wasn't going to scale 10x because I can't just get my hands on 100,000 iPhones if I want to. So we started augmenting that with virtual device testing. So running emulators and simulators. So that's super easy. I can just run it on 100,000 containers, and here's 100,000 devices. So this is an example of a place where the way that we had our traditional test infrastructure was just never going to scale. And once you start looking more carefully, there's all kinds of bottlenecks like that, where we just never anticipated that we'd be generating code and validating it at 10x. And the last pillar is a little bit fuzzy here, but I call it the non-determinism. And what I mean by this is most of the testing that we traditionally do is pretty binary. I run a unit test, I run an integration test, either passes or it doesn't. But now we are generating more and more agentic experiences where things aren't necessarily clear cut. So deciding whether an agentic change was adequate or correct is much more difficult. You have to understand what does, for example, Rufus, if you are using, Rufus is the chatbot in the Amazon store. And that's an example of an agentic experience that we can't just test with traditional testing. So understanding how to test all these non-deterministic experiences. And by the way, since we're generating code with LLMs, like every single time that we're generating that code, we're potentially getting a entirely new code base. So that's also non-deterministic. So surprise, everything is non-deterministic now, not just the things that you naturally think of, non-deterministic. And so we have a plan for how to get from there to here. I think it's going to take a lot of years, but one of the nice things about articulating this mental framework is that it gave us a way for all of us to communicate the same way. It gave us a way for us to understand the urgency of needing to move really, really fast. And it gave us a way to align. We've been presenting this to a bunch of executives, and it's been successful in the sense that, for example, one of the teams was investing on something, and basically after we chatted about all this, they're like, great, how do we double the funding on this? How do we move faster and all these things? So never underestimate the power of creating a mental framework when you're trying to move a very, very big ship. I just wanted to leave you with that. No, it's getting a little late and we're all getting tired, but I wanted to also have time for questions and debate and ideas as well. So, thank you.
Thank you.
Dan looks ready to go.
Yeah, I'm ready.
Yeah.
I'm ready. Okay. I'm gonna ask you my favorite part since we're here with the academics. Let's talk about the mutation testing.
Yeah.
How are you thinking about mutation testing? Are you thinking, I think there was actually a good paper here earlier in the week where they were looking at the different kinds of faults between an LLM mutation versus, I can't remember which paper it was, sorry, versus the traditional mutation tools, which use like templated mutation operators. How are you thinking about this? Are you trying to be like adversarial with mutation testing? What kind of bugs are you trying to find?
Yeah. So this is when we just started playing with it. And very good point. The traditional mutation testing is things like changing a less than sign to a greater than sign or something like that. The kinds of bugs that we're trying to do are a little bit more settled than that. Because I think the kinds of bugs that LLM end up creating are more settled than that. One of the things that we realized, for example, is that we have an LLM that critiques code. And unless you're a little bit sneaky and adversarial about the bugs that you're introducing, the LLM that critiques code will catch it, particularly if you have certain phrasing. So like we have to try to trick the LLM that's code reviewing. And this is an experiment. I don't have any data yet, but the way that we're going about some of these injections is we're actually not giving the LLM access to the code initially, but we're giving it access to the specs so that it thinks like a customer thinks in terms of like user scenarios more than just like, oh, I'm going to change this greater than sign to less than sign. I'm excited about that.
Yeah, there was you should look at the proceedings of the mutation workshop that was on Monday. There was a couple of different things that were on higher order mutation where they were extracting either pseudocode or a plan or a specification. And then there was a very nice one that used hazard analysis, which was something that I didn't know about, but they used this hazard idea and to make structured mutations of the specs. So, and they found that that was much better than the unguided mutations where you just ask it to make some change. Like it gave you like sort of like templated changes, but for specifications done manual. So this, anyway, suggestion.
Yeah, I love it. I think I want data because my gut feeling is that most of validation is pretty terrible and it's letting a bunch of defects through. We just don't really know. But unless we have data that we can point at a specific pipeline and say, hey, your defect escape rate is 18%, or your defect escape is 80%, then we can have a better discussion about that.
Yeah, I was wondering if you could talk a little bit more about the specs, like how widely deployed are spec-driven development at Amazon, and what form do the specs take?
We are 100% sold on that. So there's something called Amazon Kira, which is an IDE that up to recently was the only IDE that we were using. We're now also using Anthropic Claude, but up to recently we're all like 100% using Kira. Now the interesting thing about Kira is that basically it has two modes. You do vibe coding like anybody else, or you do spec-driven development. And most of us were really going for creating the specs, checking in the specs, to the point of sometimes not even looking at the code, just focusing on the specs themselves. We also have millions and millions of lines of code, legacy systems. And so we also invested in a system that creates specs from legacy code. It's called Spec Studio, and there's a bunch of talks on that as well. This is great. I had to go change a piece of code in that package that had 300,000 lines of code. And I thought, I don't have time to look at 300,000 lines of code and understand what the hell this thing does. But I do need to make this change. So I was able to generate a spec for that in 1 minute and then understand where there I need to be making that change. And so we're investing in basically creating specs for every single service that we have in the entire company.
Oh, great. And these are just natural language specifications, right?
Yes.
Follow up. Are you establishing a structured format for storing them? Or are you just taking them in markdown files directly?
That's a good question. So Amazon Kira has a very specific format that it generates. And so that's the good news. Basically creates 3 files. It's a requirements doc first, and starts with requirements. And then from that requirements doc, it creates a design doc, these are markdown files. And then from the design doc, it creates a list of tasks for actually executing the thing. And so that's pretty standard across the company. And Kiro enforces a lot of those standards.
Yeah, sometimes like, I think many of the tools, the harnesses, like they'll create those files in the background, but they're ephemeral. And I think there's like an industry-wide management problem of how to manage the evolution of those and what to do with them and all these kinds of things. It's like, yeah, that spider's nest you showed of the all microservices, it's like that.
Yeah. And that's true because they're 2 different, like people say the word spec, but they actually mean different things. So I may have a spec on what I want the future to be. This is a prompt or a spec on a feature that I'm trying to add. And so this is a feature, that's a future spec, right? And then I have specs for like what the world does today. And the specs for the feature I'm trying to add, those are somewhat ephemeral in that once I add that feature, it becomes part of this as well. So where do we keep those? How do we treat those? And it's something we haven't 100% figured out yet.
And it doesn't compose well with formal specifications either. And I know Amazon is like actually really good at formal specifications over the AWS land. You guys got the like TLA plus crew and all those people. But like the natural language specs don't necessarily compose with that. And how do you update it? And like, how do you check a natural language spec to make sure it's self-consistent and all these kinds of things? Yeah.
Yeah. There's all kinds of really interesting white papers coming from the Amazon Kiro guys on exactly that, because they are fully spec-driven development. And so enforcing a format for it, how do they think about testing the specs and so forth. And this is a big loop, right? So like when code is checked in, all these specs have to be regenerated because you've changed the state of the world. So these are outdated. And so there's sort of a big regenerated loop all the time.
So for teams looking to, I don't know, be more AI friendly in the testing space with, you know, test agent, test judge, all these things, what lessons do you think you can share about entering that world a little bit carefully?
I think the thing that we've learned is that you have to think differently about your processes, and you have to be willing to kind of blow them out whenever they don't make any sense. And what I mean by that is, like, we have this horse cart, and we got LLMs, so we just added like a 500 horsepower engine to the horse cart, and then we're like, oh shit, this doesn't drive very well, so we try to make the wheels better, and we're like, oh, this doesn't brake very well, so we just added brakes. And so, like, at what point does it make sense to just generate, scrape that and like go create the Ferrari? So these are active debates that we're having, is how much do we evolve systems? How much do we say, well, the SDLD is going to look entirely different? So like, and even like the pillars, we have very hot debates about how much we want to invest in some of these things. For me, for example, like investing in fixing testability, that's durable. Like no matter which way LLMs are going to end up, like we will need stable test environments. So looking after durable investments is a hard one, because I don't 100% know which thing is going to be durable. And like, this is my view, this would be entirely wrong. 2 years from now, we'd be having an entirely different discussion about like how agents should talk to each other. Anybody that claims they understand AI and how the SDLD will look like 2 years from now, they're full of crap. They have to be willing to evolve very quickly.
Is your hunch that it's, I mean, is your hunch that it's an adversary? Like, you have a spec dev agent, so the judge is like, is the best thing to just be adversarial against every single component, right? Like, so you have literally the dev agent, the test agent, absolutely adversarial against whatever the hell the dev agent is doing, and kind of like the old school, right?
Yeah. In fact, this is kind of like the way things used to be, right? Like Microsoft hired Estes back in the 90s, and I started my career as an Estes. And the reason they hired Estes is because they wanted a different persona that was independent from the developers to be creating the tests. And they had different incentives and so forth. And like, really, we just created like SDEs and Estes. That's it. Like we're just recreating the things that we used to do in our old SDLD, but like adapting it to agents. Other questions? Got one?
Yeah, I also found it fascinating your whole testing and prod slide. I was wondering if you could talk more about what's happening with that. Is that an ideation phase right now, or are you trying it in some parts of the company?
Yeah, I made a lot of people really nervous when I put that idea forward. I had to take it to all the distinguished engineers in the company, get them to buy into it. Because a few were like, "Are you crazy?" I said, "Yeah, I am." But like, we've tried to fix this for 20 years with the same way of fixing it, which is, oh, we're going to make a copy of prod, and like, we promise that this time we're going to get it right, and we promise. And all these efforts always start with good intentions, and they agree for 6 months or so, and eventually the person that started the effort of making a reliable test environment leaves the company. And so like, I like Amazon, I want to leave. So I think that safety is the part that's most important. Now, we pitched the idea, we got buy-in, we got funding, we hired a team of about 30 engineers in Madrid. We have multiple principals working on the problem, and we have it working for a subset of Amazon stores. And we have a goal, CEO level goal, to get this working by end of year. So we're very serious about this.
Okay. So, yeah, I mean, but, how carefully do you look at your credit card statement now? It's like, it's like maybe I should start looking at more carefully in case you start like accidentally using your credit card as your test account. But,
There's all like, we had to do a lot of security reviews. I became best friends with a lot of security people.
yeah, okay. Cause like my other thought was like, this opens up a whole new avenue for people to do adversarial external testing on Amazon to see if they can trigger the.
I'm not going to tell you what the
APIs.
test header is. No. Yeah. Like, honestly, like 90% of the effort to get this working is the safety guardrails. The actual tech is pretty simple. It's a router to route traffic. There's some challenges of doing that at scale. And there's another router, and there's a router to write data safely. But like, most of our efforts is in how to make it safe.
I'm looking at the Facebook people, but they have this like digital twin system from Mark Harmon at Facebook and like the QA environment, right? That sort of like simulates all the Facebook activity instead of being like a bunch of little integration environments, sort of giant one. So was that what you guys were trying to do, or are you trying to do more like a bunch of little ones for like breaking apart that giant service mesh?
No, one big giant one. So we're able to run unit tests, and that's fine. And we can deploy a system and mock dependencies, and we can test, integration tests. That's fine. But at the end of the day, the most interesting bugs that show up are the bugs, like you're somewhere in the middle of that ball of services, and you don't really know Like you're making a change and you don't really know if you're going to break anybody or not because there's hundreds of microservices above you and thousands of microservices below you, right? So that's the thing that's most interesting to me is how do we get this end-to-end experience? And how do we improve things? Because that's like if LLMs screw up, that's where they're going to screw up because they don't have enough context on the whole world. They're making things up, they're guessing. So I'm not worried about LLMs writing code that will fail a unit test. That's a sole problem. I'm more worried about them creating tests that are going to have subtle problems with a misunderstanding of the way the ecosystem works and how services interact with each other. So that's what I'm worried about.
Thank you so much, Carlos, for the presentation. My question also goes into the direction of test and prod. So suppose I have the proxy and it switched to the like SUT path. Now you get a response and the behavior. How do you know if that behavior was correct? What's your oracle when you do this test and prod? So do you just run the request against both like the traditional and the new system and you check for equality of outcome, or is there, or that it just didn't crash, or yeah?
Yeah, no, we don't do that. That's diff testing. We do that, but it's there's a different thing that we're trying to go here, which is we run just so these are end-to-end tests. So we're expecting a user scenario to work, and so that's the kind of testing that we're going on.
Thank you so much.
Oh,
What's that? Last one.
I don't know those user slides, because I think in one of your slides, you showed that you just defined prompt as the test. Or like, it wasn't clear whether you're using prompts to just create the test and then log this as a test, or is the prompt the test?
oh, okay. This is the test auto generation.
Yes.
Yeah. We're debating this one as well. Some people are in the camp that the prompt is the test. Actually, the extreme view here is that the requirement stock itself is the test. And like, do we even need to create tests? Or do we just give the LLM the requirement stock and say, figure this out? It's kind of pie in the sky, but I don't think we're actually that far from it in real life. There's a lot of places we've been moving away from generating code. For example, UI testing, we specifically are moving away from generating code. We don't generate Selenium app view Playwright. We feed natural language to an LLM and let the LLM navigate the store. It's just, there's so much more interesting test cases that the LLMs run into. Fun fact, the very first time we run this, LLMs are creative, right? And we say log in with this username and password, and either the username or the password was not right. So it failed to log in. So the LLM's like, cool, I can see there's a create account button here. So I'm going to create an account. And it did, and that failed. And then the LLM being creative and being task driven was like, oh, cool, I see that there's a chat with agent here. And it started chatting with an agent. And at that point, we're like, this is cool, but we really need some guardrails around how we're going to have LLMs navigate the store and run tests. That's an entirely different talk. But that was fun.
Yeah, because this wouldn't happen with Selenium test, which is just like one path, right? Like the agent can explore many paths.
Yeah, and the thing that made UI tests like so flaky is exactly that you've specified this very exact path. So anytime that like a message box pops up or like you change the layout, like it used to be the case that you give username and password and hit login, and at some point we changed it so that you give your username, hit enter, and then the next screen you specify your password. That broke hundreds of thousands of Playwright Selenium tests, and we spent like months fixing those. LM doesn't care. It's like, oh, cool, like I'll navigate this. So, yeah.
All right. Thank you so much.
Thank you.